Welcome to the 19th lecture. We are studying stochastic processes and we'll continue studying Markov processes. There is a small recap from our last lecture. We studied about recurrent and transient states. State I is recurrent if for the state I, if for that very state I the set of states that are reachable from I, if we represent that as A of I, then for all members of the set of states that are reachable from I must be in the set of reachable states. If J is reachable from I, in other words, if J is reachable from I, then for all those J's that are reachable from I must also be reachable from those J's. Right. Here is a small example. We will continue our recap with a small example that we have this Markov chain 1, 2, 3, 4 states. Right. So if we suppose I is equal to 2, start for this state. Let's find out this whether this state is recurrent or not. If it is not recurrent, it's transient. We already know that. So what are the set of states that are reachable from 2? This is 1, 3 and 4. These 3 states and 2 itself. So 1, 2, 3 and 4. So let's see what is the set of states that are reachable from this first element 1. It's only 1. So we don't need to solve any further, although I have solved in the notes, but we don't have to find out A of 2, A of 3 and A of 4, because it tells us that since 2 is not in the set of one of the elements that are in the set of A of 2, that in the set A of 2, this means, so 2 isn't there. This means 2 is not recurrent. If it is not recurrent, it is transient. However, state 1 is recurrent because from state 1 we can go only to state 1. So the set of reachable states from 1 is only 1. So it's a recurrent state. What's about this 3? Whether this is a recurrent state or not. From 3 we can go to 4 and that's all. And then from 4 we can go to 3. So even 3 is a recurrent state. What's about 4? From 4 we can go to 3 and from 3 we can come back to 4. So the set of reachable states from 4 contains only 3. And in the set of reachable states from 3, 4 is there. This means 4 is a recurrent state. So all 1, 3 and 4 are recurrent states, whereas 2 is not. It's transient state. Right. In this lecture we are going to study Markov decomposition of Markov chains. How can we find parts in Markov chain? There can be certain classes that we can have in a Markov chain. In a Markov chain MC, let's call it MC. So MC can be decomposed in class of recurrent states and transient states. This can be class or classes. So it can be decomposed into class or classes of recurrent states and some transient states which cannot be put in classes. So right. Recurrent states in a Markov chain can be put in classes. Each state such that recurrent states classes. Recurrent states classes. Each state, certain recurrent states, not all, certain recurrent states can be put in one class, and there can be more than one classes in a given Markov chain, right? But what is the property of one of the states that are in a given single class? Each state in a class must be reachable, from all other states. So suppose we are given this chain containing these 4 states. Right. Let's see whether this chain can be put in, where these 4 states can be put in one class. First, we have to see whether each of these states is a recurrent state, right? In 1, we see that from 1, 2 is reachable, and 4 is reachable, and 3 is also reachable. So in A of 1, we have 2, 3 and 4. So these are the reachable states from 1. Let's see what are the reachable states from 2. From 2 we can access 1, 2 itself, 4 and 3. So from 3 we can access 2, 1 and 4 and 3 itself, 1, 2, 3, 4. And from 4 we can access 1 and then 2 and 3. So 1 is a recurrent state because 2, 3 in the sets of accessible states from 2, 3 and 4, 1 is there. Similarly, 2 is also a recurrent state. We can verify 3 and 4, 1, 2, 3 and 4, all states are recurrent because they are accessible from each other. So since all of them are accessible from each other, I can use a different pen to draw a boundary around this chain. So even if it is a part of a bigger chain, we'll draw a boundary across it to tell that it's a class of recurrent states, because all recurrent states in this class are accessible from each other, right? Regarding decomposition of Markov chains, we have to discuss three other points. So point number 2 is that a recurrent state is reachable from states in its own class only. Right, if we have a chain like this, one, two, three, 4, 5. Right. In this chain, we can very easily verify that this is a recurrent state. These 2, 4 and 5 are also recurrent, but they can be put in one class. Maybe we can call it class 2, maybe we call it class 1. But 2 and 3 are not recurrent. They are transient, because in the set of states that are accessible from 2, 1 is also included, but in the sets of states that are accessible from 1, 2 is not included. Therefore 2 is not recurrent, 2 is transient. Similarly, in the set of states that are accessible from 3, 4 is included, but in the set of states that are accessible from 4, 3 is not included. Therefore 3 is also not recurrent, it's transient. So 2 and 3 are transient states. So all the states that are in one class of recurrent states are accessible from each other, but the states that are in class 1, they are not accessible from the states that are in class 2. You can verify that. And similarly, the states that are in class 2 are not accessible from class 1, and vice versa. So this is another important point. And the third point regarding decomposition of Markov chains is that a transient state is not reachable from any recurrent state. We see that these 2 are transient states. They are not accessible from any, they are not reachable or accessible from any transient state. However, we can reach to a transient state, to a recurrent state from these transient states, but vice versa isn't true. And the last is regarding the vice versa. Our recurrent state is accessible, is reachable from transient state. And we have to add a small word with this. That word is at least. At least one recurrent state is reachable from transient state, like we can see here, and they can be more than one. We'll keep on studying Markov process in upcoming lectures. Thank you.